In this video, we will demonstrate how to improve a Google Scholar search using different keyword techniques. We will use big data as our main topic and gradually make the search more specific. We will begin without quotation marks, then add quotation marks, followed by one and, two ands, and finally two ands combined with OR. This allows us to see how each technique changes the search and helps us find more relevant literature. We begin by searching for big data without quotation marks. This gives us a broad range of results because Google Scholar is searching for the individual words big and data. Although this can provide a large amount of information, not every result will necessarily focus on big data as a specific research topic. Some papers may contain the word big and the word data in different parts of the paper without specifically discussing big data. This means that we may have to go through a large number of results to find the studies that are actually relevant to our literature review. The number of results shown here is over 11 million. To make the search more precise, we can use quotation marks. We now place quotation marks around big data. Quotation marks tell Google Scholar to search for these words as an exact phrase. Instead of treating big and data as separate keywords, Google Scholar now focuses specifically on the phrase big data. This makes the search more relevant because we are specifically looking for research discussing big data as a concept. We can see that the number of results has changed from our original search. The results are now approximately 3 million. Although there may still be a large number of studies available, the search is more focused than the previous one. This demonstrates how quotation marks can be used to improve the precision of our keyword search before we begin adding additional concepts. Next, we add another keyword that is related to big data. For this example, we use data analytics. Our search is now big data and data analytics. The AND operator tells Google Scholar that we want results related to both big data and data analytics. This makes the search more specific because we are no longer looking for general big data research. Instead, we are focusing on studies that connect big data with data analytics. This can be useful for literature review because data analytics is an important area when investigating how big data can be processed, analyzed, and used to produce meaningful information. The number of results is now approximately insert result count. As we can see, adding and helps us narrow our search and focus on a more specific research area. We can make the search even more specific by adding another keyword. This time, we add machine learning. Our search now becomes big data and data analytics and machine learning. We now have two AND operators connecting three different concepts. This means that we are looking for research that is relevant to big data, data analytics, and machine learning. Adding this third concept makes the search more targeted. For example, instead of finding papers that simply discuss big data and analytics, we are now focusing on studies where machine learning is also relevant. This can be particularly useful if our proposed system involves machine learning techniques for analyzing big data. The number of results has now been further reduced. The important point is that every keyword we add should have a clear connection to our research topic. We should not add keywords simply to reduce the number of results, because doing so could remove useful studies. Finally, we can use OR together with our two AND operators. Our search can become big data and data analytics and machine learning OR artificial intelligence. We are still using the two ANDs to keep the search focused on big data and data analytics. However, we are now using OR between machine learning and artificial intelligence. OR allows either of these related concepts to appear in the results. This is useful because different researchers may use different terminology when describing similar technologies. For example, one paper may discuss the use of machine learning with big data, while another may discuss artificial intelligence. If we only search for machine learning, we could potentially miss studies that use artificial intelligence as their main terminology. By using OR, we can include both groups of studies. The number of results is now changed as well. This demonstrates an important difference between the operators and narrows the search, while OR can sometimes broaden the search by including alternatives.